Okay, this next video is actually not covered in your book, but I wanted to just at least give you a heads up about this. So the next section in your book is normal distributions of data. And for me, I think that maybe this would have been better if we had broken this one section into first some box plots and then talked about deviation and then talked about normal distributions. So that's what you're about ready to experience. So this box plots is not in your book, okay? That's why, that's not exactly why it's covered at the discretion of the instructor, but it's in Appendix B. So these notes are in the back of your notes packet, but nonetheless, here they are. So here comes box plots. Let's talk about it. We're going to talk about quartiles, we're going to talk about dispersion, and then we're going to, of course, create and interpret some box plots. So let's look at this example, because I really think that this example gives you a really good motivation for why we're even doing this to begin with. 20 students in a class, all of them score a 70. Write out the data set. We can do that. That's 4 of them. That's 4 students. We need 20 of them. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, oopsie, 16, 17, 18, 19, 20. Okay, accidentally almost put in a 75 there, but nope. 20 students in a class, all of them score a 70. We wrote out the data set. Find the mean and the median. Okay, well, it's clear to me that the middle number is going to be a 70. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we just cut the data set right here, this is the low 10, the high 10. Actually, it's all a bunch of 70s. But there they are in the median. So immediately, I don't even have to do anything. The middle number is 70. And if you add up all of these 70s and divide by how many 70s on average, you will get a 70. So the mean here, 20 students in a class, and this is all of them, so I'm going to use a mu, 70. Okay? Now, number 2. There are 20 students in a class. Half of them scored a 50. The other half scored a 90. Write out the data set. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I know that that's half of my data set. So, and I'm about ready to compute the median, so I'm going to go ahead and put this here anyway. 10 50s, and the other half scored 90s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, got it. What is the mean and the median? Okay. So the median is exactly the middle between 50 and 90, which I believe is 70. But just to write this down and be sure, halfway in the middle between 50 and 90 would be 140 split in half. That is 70. Okay, so the median is 70. And the mean is, okay, well, we're adding 10 50s, or we're adding 50 10 times. So 50 10 times, plus adding 90 10 times, and then we're dividing by 20. That's how many students there are. Okay, I'm going to get my handy calculator. 50 10 times plus 90 10 times is 1400. So 1400 divided by 20. Oh, look at that. 70. Okay, so the median average is a 70 and the mean average is a 70. And up here in this class, the median average was a 70 and the mean was a 70. Now let's look at it again. Oh, look, I'm already doing this without even thinking because, like, oh, look, they match. 20 students in a class. 10 score a 70, 5 score a 65, and 5 score a 75. In order to find the median, we have to write them from low to high. So I'm going to start with the 565s, then the 1070s, then the 575s. So here we go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 575s. 1, 2, 3, 4, 5. Okay, there's our data set. And let's find the median first, which is directly in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 below this marker and 10 above this marker. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. And that means that the median is a 70, because that is exactly in the middle. And the mean, okay, the mean, there are 5 65s added. So this is 65 added 5 times, plus 70 added 10 times, plus 75 added 5 times, and that is all divided by 20. Okay, I'm going to get my handy calculator and add up that numerator, and it looks like I get 1400. So that means that the mean average is 70. Okay, compare these data sets and their averages. What do you notice? Well, something very obvious is happening. The medians are all 70, the means are all 70, but the data sets are different from each other. As a matter of fact, when I'm in the classroom, I always ask my students, think about it. Which class would you yourself want to be in if these were the averages and these were the scores? And they always make a decision. You should make that decision for yourself right now. As I write all means and medians were 70. So the 70 tells us a summary of this data, each one of these data classes, or, you know, the data for the scores on an exam for each individual class. But the data sets are different and the scores are different. So, I mean, I wouldn't say that because their medians and means were all 70 that they're all the same class performances. My risky students, they pick example or number 2 from this example because they're like, I bet I would have been a 90 and some other person would have been a 50. So my riskier students or my more competitive students, they always pick number 2. The ones who are like, you know what, everybody deserves, everybody should, you know, pass. They all pick 1. And that also guarantees that they would have passed. And then some of them are like, yeah, but somebody's always a little bit better than another person. So I'm going to go with 3. So it's really, that's an opinion question here. But comparing these data sets, we see that they are not all the same. Each class performed differently. So the means and medians are all equal, but each class performed differently. So that performance is not captured by their mean and their median. That alone will not do it for us. And even if you use the mode, I guess the only one, the mode, so in number 1 and number 3, the mode would still be 70. And number 2, it would be bimodal 50 and 90. Which brings us to this idea of dispersion. So if the mean and median aren't enough to describe a data set, then let's talk about how spread out they are, how dispersed these numbers are in the data set. 1 minute, please. And so dispersion is a measure of how spread out values are. Okay, that preassumes or presupposes that the data that we have are numerical values because it says they're spread out. So less dispersed is close together, and higher dispersion, so a bigger number for dispersion, means far apart. Okay, so that is how we're going to define it. In the next video, since I'm having someone knock at my door relentlessly, we will talk about common measures of dispersion, and then we will apply it to our Betty's barbecue wait times and Big Back barbecue wait times.